Good afternoon or good morning, depending where you are today. Thank you for joining us. This is Matt Hiley from Tantalus Systems, and we're going to start our webinar. Today's webinar is called Why Utilities Need to Adopt Grid Data Management Systems. And I'm happy today to have a couple of folks I'll introduce in just a second who are going to take us through the presentation. A couple house items. This is being recorded, so I will share the recording with folks after the call, as well as the PDF of the presentation itself. Thanks again, everyone, for joining. If you have questions, I've enabled the chat. You can either submit questions through chat and we'll answer them as we go through the presentation, or there's also a Q&A button. I'll be monitoring both of those. So if whatever works for you, go ahead and submit questions there. We have today the pleasure of both Nate Pleasant from Digi joining us, as well as Doug Campbell from Tantalus Systems to take us through our webinar and talk about grid data management systems. So in the interest of everyone's time, I'll turn it over to Doug, and we can go from there. Doug, thanks. Go ahead.
Thank you, Matt. Good morning, everybody. I'm Doug Campbell. I'm the Chief Solution Officer for Tantalus. I joined Tantalus about 3 years ago when Tantalus acquired my company, which was called Congruitive, and that's a company that I founded in 1990. My background is in utility operational data technology systems, and I've been a provider and developer and marketer of systems for 45 plus years now. And also joined by Nate Pleasant. Nate, go ahead and introduce yourself.
Yeah, thanks. Nate Pleasant. I'm the product manager at Digi International for our Dell operating systems. That's the firmware that runs on many of our cellular routers and box products today. I've been with Digi since 2010 timeframe, and been in that industry as far as cellular connectivity and peripheral device equipment connectivity for that time. Do we want to do a bit about background on companies, or go ahead, Doug? Yeah.
Sure. Yeah. I think we've got background slides coming up on each company.
Yeah.
Okay. All right. Okay. The obligatory legal notice and disclaimer slide. And let me start off with a quick overview of Tantalus. Tantalus has over 310 utility customers. Over 130 employees across Canada and the United States. In 2021, we started trading publicly on the Toronto Stock Exchange. We have a 35-year plus history, 3.5 million connected devices, and through our grid data management systems, more than 45 billion data samples delivered per day.
Thanks. And yeah, Digi has been in industry here since 1985. Been to be your IoT solutions provider at the heart of it all to provide mission critical wireless connectivity and products for services for those IoT connections. You can go to next slide. So just a note, we're a publicly traded company on NASDAQ, globally minded, as many of, our customers here are, and have presence throughout the world. It's a bit of a unicorn. We've been in cellular products for 21 years and been coming profitable of that, for many quarters there. So it's truly a great company to be a part of.
Right. Thanks, Nate. So let's start off by taking a look at the drivers that are creating urgency for utilities. First one is extreme weather. I think today is probably a good example with much of the country blanketed in snow and many areas that don't typically see snow. Out in the western U.S. where I am, we've seen a lot of changes in extreme weather over the last decade or so. We're also seeing the electrification of everything. There's a big push on to add electrification across devices and utilities, decarbonation of everything, and as well as a aging infrastructure and also an aging workforce. These are really the factors that utilities are taking a look at right now. Now, the DOE a while back created something called the Grid Modernization Initiative, and it had a number of factors that they defined as necessary for grid modernization. And these include resiliency, reliability, security, affordability, flexibility, and sustainability. And really, when you get down to it, grid modernization's the goal. And you can't modernize the grid unless all of the data works together. And that means getting the data from all the devices that have data and getting that data to the systems and the applications that need that data. And that's why we created the TrueSync grid modernization system, grid data management system, excuse me. So how did we get here, and why did we get here, and what is a grid data management system? Why do you need one? So let's start with the historic approach. So historically, systems were all deployed within separate silos. Now, this made sense at the time because you typically would go to a single vendor. You'd buy the computer system, the software, the applications, the communications, the devices, and you'd connect it all up, and you'd have your SCADA system, you'd have your meter data management system. And so these silos made sense at the time. Now, what's happened since then? What's really changed? Well, first of all, the number of applications and the systems that need data has increased dramatically. And at the same time, utilities are no longer buying systems, complete silos from a single vendor. Utilities are buying best of breed applications, best of breed devices from a wide variety of vendors. And the number of devices out there that have real-time data is increasing exponentially. We're also seeing a need for a breakdown of the silos because multiple applications need the same data from the same devices. And also something has come up over the last decade or two is really the need for cybersecurity all the way from the edge device to the cloud. Now, if we take a look today, it is not unusual to see these silos with this many applications in it. This is actually a very realistic list of all the different applications that are in use within utilities today. So what's the real problem, and what's the solution for it? So the real problem is data fragmentation, because as the utilities began to find, well, we've got all this real-time data, we've got all these different systems, how do we get the data to them, and how do we break down these silos? Well, the first pass at that was to say, okay, well, let's just cross-connect everything. Let's just take any system or any application that needs data, we'll connect it directly to the device that has that data, and everything should be fine. Sounds good, but in practice, there's a couple of serious problems with it. One is that often the devices are not designed to have multiple masters connected to them simultaneously. And even those that do, and the protocols that support that, you often end up with a big configuration challenge. You're having to maintain multiple point lists, multiple databases within each one of the real-time devices, and it really gets out of hand quickly, especially as these systems begin to proliferate and scale. So, what are some of the other challenges that the utilities are facing? One is skyrocketing system integration costs. Each one of these silos that are being deployed as a separate silo. There's no reuse of the integration technology that's been placed in there, and so this means that each silo is an entirely new deployment, and so that is with the with increasing labor and system integration costs, that's becoming a problem. The other thing that's happening is the utilities are beginning to integrate the information technology side of the house, the IT side, and the operational OT side of the house. There's also a need for support for OT-based communication technologies and protocols for DERMS, SCADA, EMS, things like that. There's also a need to integrate DERs with DERMS and also integrate DERMS and ADS and corporate applications so that there's now not only an integration of the devices that have data to the systems that need that data, but there's also a need to integrate across the systems so that the data can be sent to all the systems that need it. There's also at the same time data being produced by many of these applications, and there's a need to take that data being produced by the applications and distribute that out across the utility also. There's also a very unique thing happening, and that's the need to get both DER and EV charging data from unsecured locations, often over the public internet, and somehow integrate that into the most secure levels in the OT environment. And the last one here is that this technology needs to be scalable to millions of devices, especially as IoT devices come into play. So, what's the solution? Well, we believe it's the TrueSync grid data management system. So what we've done is we've taken the data acquisition layers and the data management layers and the device layers from the silos, and we've brought them down below the silos, and that's the purpose of the grid data management system. The purpose of the grid data management system is to make a single connection to each one of the devices that has data, acquire the data using an appropriate protocol and data model, bring that into the grid data management system, also offer a layer of data services in there, and then serve that data through a single connection to the systems and applications that need that data. Now, as part of this, the grid data management system, even though it's shown as a layer here, is actually deployed as a distributed application. So there's not only components in the middle layer, there's also components that are deployed at the edge, co-deployed with the devices that have data. This is where our Digi partnership comes in. There's also components that are co-located with the systems and the applications that need that data. So what are some of the important aspects of a grid data management system? Well, the first thing is to provide data interoperability from any device, from any vendor, using any protocol over any communication networks. A bit of a technical detail here. It's implemented as a federated data fabric, but the important point is it provides a single source of truth for the utility. And this is very important today because you have all these different systems, all these different applications that are looking at the present state of the grid, and it's important that they're all operating off the same set of data. Otherwise, they're going to come up with different answers to the questions that they're answering. The grid data management system also has utility grade security and encryption from the device to the application. It has IoT scalability up to millions of devices. It provides an overall reusable integration technology, providing near real-time data delivery with minimal latency, data transport from behind the meter to the cloud, and protocol and data model translation. Now, I mentioned a minute ago that there's one of the pieces of the grid data management system is deployed coincidentally with the devices. And this is where our partner Digi comes in. Digi has a series of industrial cellular routers with support for something we call containers, and a software component of the grid data management system actually runs within a container within the Digi routers. And I'll let Nate talk about that in the next couple of slides.
Oh, thanks, Doug. Yeah. So to kind of complement what he's talking about, where this TrueSync becomes this common communication and platform for getting all this data out from disparate systems, the DigiCellular router is more the hardware component to help facilitate that. Like Doug mentioned, the TrueSync component can run as a container inside of our Digi industrial router, but more added to that, or from the hardware side, I think that all these different components and data, sources have different protocols that they communicate on, whether it's MQTT or Modbus or serial direct communication, or just straight TCP traffic or UDP data that it's sending out. So it needs to aggregate all that info into some thing that can then transmit that data out to the system at large that TrueSync can then take advantage of. So the Digi industrial router has many different ways of connecting to equipment. I mentioned Digi's been in business since 1980s timeframe. So we've had through our changes of time over the years as far as what things are connected and what protocols are used. So there's lots of serial capabilities that the Digi cellular routers and industrial routers support, from anything from RS-232 serial with DB9 to RS-485 with RJ50 and RJ45 connections. So there's a myriad of serial-based connectivity options that it has to do, as well as different modes for getting that data from that serial equipment and communicating that out over a network connection. And speaking of network connections, that's another big value add that Digi provides, is you don't have to hook into an existing connection that might be at the site, though that's certainly possible. The main benefit is with the cellular connectivity, you now have a dedicated line to get to that data that TrueSync can then offer. So you have options for connecting to the standard cellular networks out there, carriers out there in the world, or MVNOs. We also have options for private cellular connectivity, which is a big adoption rate for industrial solutions these days. Just how disparate they are in location, in rural facilities and oil gas locations, where there might not always be a native cellular tower available. You can have a private cellular network that extends the connectivity for those sites and locations. So it provides you with a comprehensive solution that you can deploy at any solution or area. You can go to the next slide. Thanks. Yeah, and to build off the comment about running an application inside the Digi industrial router, these Digi devices are not just a black box. They're the full connectivity solution for this entire ecosystem for industrial-based applications and all. And when I say that, we really have to start kind of at the source. When you look at choosing a hardware component for your solution, it has to be secure from the start. And that means, getting it from a secure source, Digi being a US-based company with TA compliant routers and equipment, as well as complying with different security standards for best-in-class, security conformance. And the world's, example is that is FIPS 140-2, doing external penetration testings and adhering with those best-in-class security practices out in the world. And then extending that onto, again, that's not just a black box. It's something that can be customized for the solution that you need, running those different applications on there. So that's where containerization comes into play, where you can have that TrueSync application running in there to gather all that data from those disparate connections and different equipment on site, and creating that into a more comprehensive and feasible system that is expandable and scalable. And then optimizing the cellular connection or the network connection as well. Digi is a leader in reliability for mastering the actual network connection, keeping that stable, whether that's on cellular or fiber or Ethernet. Whatever internet connections you have available for sites can be utilized and even bonded together with the cellular device for enhanced reliability and latency reduction, as well as hot failover. And then management, just like with TrueSync, getting all this data, into a place where it can be managed more coherently and cohesively all together. The Digi routers themselves can also be managed with our Digi Remote Manager portal for the true scalability of managing your fleet of devices. So you're not having to do any local device management. It's all can be controlled through our Digi Remote Manager system and portal for maintaining firmware compliance, security updates, as well as configuration compliance with the standards that your company has instilled on the product.
Okay.
Hey,
Thank you,
hey,
Nate.
Nate, this is Matt. You might have said this, but a couple of questions came in.
Yeah.
One was, uh, and I think you answered this already, but would would I be able to utilize this solution in a private cellular network?
Yes, you can, and in fact, private cellular networks are being adopted more and more, especially in the industrial market, just because it provides that ubiquitous connectivity where there might not always be a native connection. Think, if there's oil gas field out there, it might not have access to a cellular tower from your local carrier available, just because there's not a tower in the area. Well, with a private cellular network, you can extend that connectivity to the site from a private cell network that the user is now in control over, so it conforms with best security practice that may be out there for isolating network traffic and communication from the outside world. So there's a lot of benefits that private cellular can provide to industrial opportunities.
Yeah, thank you.
Yep.
And was there another question, Matt?
Yeah, hold on, Doug. Let me, sorry, get off the chat for a second. Okay, there was another question. It is, uh, and this is again for Nate. Is it possible to run additional IoT applications from Digi with Digi alongside the TrueSync application?
Yes, it certainly is. Again, with the Digi containers feature and functionality on the Digi industrial routers, you have the ability to deploy one or multiple containerized applications. So, benefit of a container is each application is its own isolated environment for security best practices, as well as optimization for dedicating resources for those applications. So, really, limitation is just how much each application you want to deploy onto the Digi industrial router would consume. So just like if you're trying to run a bunch of applications on your computer or your phone, the more you add, the more resources each one consumes. So you have a limited amount of CPU drive and local storage and RAM. So just a matter of making sure that that conforms. To help with that, we have a documentation as well as details on our data sheets about each Digi industrial router, how much resources and system capabilities each one has as far as throughput and RAM constraints and all. And then we also have a SDK or software developer kit for helping with getting started with deploying containerized applications onto your Digi routers.
Okay, thank you, Nate.
Thanks, Nate.
And we also make use of the ability to run additional containers in the Digi edge routers for doing things like pre-processing of data, also for things like doing localized control and things like that. I want to step back for just a couple of minutes here and talk about a couple of very important points on this slide before we move on to the next slide. First, one thing I want to talk about is the Digi Remote Manager. The deploying and managing these large systems these days is a very different task than it was in the past. In the past, utilities were dealing with hundreds of devices, thousands of devices, tens of thousands of devices, maybe. Today, we're looking, as I mentioned earlier, up to millions of devices. And so, in addition to being able to need to get all the data from all these devices. There's also a need to manage the deployment of those devices for provisioning, software upgrades, patching, and even upgrades to the contents of the containers. And Digi has a complete comprehensive solution called Digi Remote Manager, and that becomes an important part of the whole ecosphere in deploying a large utility system. And then the next topic I want to talk about is perhaps one of the most important topics, and that has to do with cybersecurity. Folks, our grids are under attack every minute of every day. Just think about that for a second. Every day I talk to utilities and I hear about how many times a day they're being attacked. Cybersecurity is no longer an afterthought. It's no longer an add-on. It's something that has to be built into the core of the entire solution, from the devices to the applications. And this is something that we've been working on at Tantalus for several decades, building cybersecurity into our products, and also ensuring that there is a secure environment all the way from the devices to the applications. We participated about 10 years ago in a study that was being done at the National Renewable Energy Laboratory. And the scope of this study was to take a look at the effectiveness and the best practices standards and recommendations for cybersecurity. Because they found that while individual manufacturers were doing, varying degree of a good job securing their products, no one was really taking a look at the entire end-to-end security of it. And with the utilities buying and deploying products from a multitude of manufacturers and a multitude of vendors, using a multitude of communication systems and methodologies, lots of different protocols, there was a need to take a look at how do you secure this entire thing. And so that participating in that really opened our eyes as to the vast array of threats and all of the challenges being faced by the utilities. So we began working then on securing our part of it, which is the data transport part of it, in addition to, of course, making sure that each of our applications and each of our systems were bulletproof in terms of cybersecurity, but also through the grid data management system, making sure that data is secure. So I mentioned that we do have, it is a distributed solution with different pieces running in different locations. One of them being within the Digi cellular routers. There's also instances where we're actually running within the end device itself, because there are times that there are either OEMs that we work with that have opened up their internal device environment and are running an instance of our software there, or other types of things such as containers. So because of this, we want to get that data secured as close to the point of data acquisition as possible. So in places where we're running co-located with the device itself, running in something like the Digi iX30, we also make use of last foot technologies such as SecMac, which is a hardware level security, and also of these security built-in securities of some of the more advanced protocols, such as 2030.5. This makes use of TLS encryption with certificates. But the idea is to get that data encrypted as soon as possible after it's been acquired, if it's not already encrypted during the data acquisition. So the TrueSync software immediately encrypts the data, and then throughout its lifetime, when it's within the grid data management system, it remains encrypted. There's already a lot of NERC CIP and NIST standards about encryption of a data. NERC CIP requires that data be encrypted when it's at rest and when it's in motion. We've actually gone one step beyond that. We actually encrypt data in use, so that when the data is existing in the memory of the computer or the device on which the software is running, it's also encrypted at that point also. So the entire time that it's being transported, it is completely encrypted. One of the other things that we do within the grid data management system is we provide protocol and data model translation. In today's world, there's a lot of different devices speaking different protocols, and while there are standards for protocols within certain areas, with the wide variety of areas that we see across utilities today, there's a need for support for many different for basically all of the protocols that are standardized, as well as a lot of the legacy protocols, so that these grid data management system can be deployed across existing devices. So those are two of the data services. The need also for data model translation is that different devices, even though they are fully protocol compliant, often have different ways of expressing the data that they have available. And there's lots of different examples of that. Also, their different applications are expecting data in different data models. And so by having data model translation, it ensures that as the data is being acquired, it's understood what the model of the data is. And then as the data is being served to the systems and the applications that need it, it's being done in a fashion that the application is going to understand. And that cuts down a lot on the integration time and the integration complexity. So let's take a look real quick at some of the use cases. Let's take a look at DER integration. We have a couple of large West Coast IOU utilities. One of them is we created a head end for a large direct connection DERs using IEEE 2030.5 under the CSIP Rule 21 compliance, being used to unmask hidden loads at customer sites, and also support for the California public safety power shutoff programs for wildfire mitigation. We have another East Coast utility where we're doing the grid data management system is doing protocol harmonization in a head end for residential solar, direct connection to 10,000 customer-owned smart inverters, and harmonizing data, doing protocol and data model translation across several of the IEEE 1547 protocols. So in this case, 2030.5, DNP, and Modbus, and giving the ability to update operating curves. So in this case, there's an ADMS system at the head end that only speaks DNP, and there are smart inverters out there, some of them speaking Modbus, some of them speaking 2030.5, and the grid data management system is doing its thing in between there. Down in Australia, at a utility called United Energy. There is a very innovative program going on where the utility is deploying battery storage on the distribution circuits and connecting it into their DERM system. And the grid data management system is providing protocol data model translation, as well as this is a case where part of the grid data management system is running within the energy storage system itself. So it's providing complete encryption end to end. Also with support for things like for file transfer. Another case is this is kind of a summary of the previous slide. Um, Talking about the fact that we have head ends and grid data management systems that are doing direct connects for our solar pole top batteries, also large behind the meter types of resources greater than a megawatt, and also doing aggregation for DERs. And the grid data management system is the middle layer in all of this. And then the last use case I want to talk about is where the grid data management system is being used in a standard-based communication and configuration of substation devices. This is a project where the grid data management system is being used at a large West Coast utility, and it's incorporating the IEC 61850, not only the protocols but also the data models, and the ability to have a automatic configuration of an entire substation. Before something like this, it was necessary it would typically take weeks to months to completely configure a substation. Using the 61850 data model and protocols, it's possible to model the data, model the substation, download those modeling files, and automatically configure all of the devices in the substation, as well as the grid data management system, and then have the substation up and running within a matter of hours. And also another application for the grid data management system.
Doug,
Okay, so
we had
yes.
a couple more questions come in if I could break in. There you go.
Well, guess what? How about some of those questions, Matt?
Perfect timing. I did have a question that came in that said, okay, we've got Tantalus and Digi on the line together, and we're talking about a solution or joint solution for utilities. How did that actually come together? And then, what are you doing from a unified perspective to bring a solution to the market?
Okay, so we've obviously been doing data acquisition for a very long time. And we've actually been working with Digi for close to 3 decades. We way back when we started, and we introduced our first SCADA product, there was a need for multiple serial ports on an IBM style computer. And we first started working with Digi because they had serial port expanders. And we could take a PC type computer that maybe had 2 to 4 built-in serial ports and expand it to 64, 120, 128 serial ports. And so that's when we began working with Digi. And then through the years, as Digi began growing, and then we started working with Digi on edge communication gateways. And so that relationship has blossomed. We've standardized on Digi as one of our partners, and one of the hardware connectivity products that we support. Now, in terms of specifically where we're at with this, is we are a Digi partner, and a lot of the solution deployment and sales for Tantalus products, especially in the IOU markets, are being done through system integrators, and so there's several system integrators that have both Tantalus products and Digi products, and so in that case, we're all working together. And there's also another reason for the system integrators is that the system integrators provide value add for not only the deployment of the systems, but also for the ongoing configuration and maintenance of the systems as value added services to the utilities. So did that answer the question?
Yeah, I appreciate it. Thanks, Doug. We had another question come in around from a utility that has Digi routers integrated with various different meter types. Is there any requirement in terms of the vendor for an AMI or SCADA application? Is this agnostic, or is there some type of particular AMI system or SCADA system that needs to be deployed?
The grid data management system is completely agnostic when it comes to it works with any device, any protocol, any application, any vendor of applications or systems. So any AMI, any DERMS, any ADMS, any meter data management system, any outage management system, because it is simply acting as a data acquisition, data transport, data management layer that is compatible across the entire utility.
So one of the things when you say that, Doug, I think back to your slide that shows how TrueSync sits in the middle of the application and devices and gets rid of that spider chart of connectivity from each device to each application. So when I send the slides out following this, folks, just remember that slide encompasses or encapsulates, I think, Doug, what you just said from a visual perspective.
Yeah, that's what we adoringly call the spaghetti slide.
The spaghetti slide. Okay, I'll have to update my vocabulary. Thanks, Doug. That was, folks. If you have any other questions, you can let me know now. I don't see anything else in chat. Of course, afterwards, I'll follow up with the link to the presentation as well as the PDF of the presentation itself, and you can always respond to that email from me with any additional questions you might have. Doug or Nate, any other final comments? Nate, anything you'd like to say as we wrap up here?
Nice. Thank you, everyone, for your time. Thanks for attending. And if you have any questions, follow up. You see the contact info there. You can also, if you have questions about the Digi industrial routers, you can go to our Digi website, and happy to have you contact our sales or support team with any questions you have.
Okay.
Doug, any final
Yeah.
comments?
Thank you, Nate. Pleasure presenting with you. I think just to leave you with a couple of thoughts, takeaways from this. One is that the grid data management system is designed to solve a number of issues, number of problems facing utilities. One is integration costs. Second one is integration complexity. The third one is to ensure that you have a single source of truth for the data within your utility. And the fourth one is, of course, cybersecurity. And these are the problems that the system is designed to solve for the utilities. Thank you all again for attending, and please feel free to follow up.
Yep. Thank you, Doug. Thank you, Nate. and the folks from Digi for participating and contributing in today's webinar. I will share this with everyone as I mentioned. And again, if you do have any questions, you can reach out to Nate, Doug, or myself, and we'll follow up with you. Thank you all for your time today. Enjoy the rest
Okay.
of your afternoon.
Thanks, everybody.
Cheers all. Bye.